Hey guys, it's Ronak here again, and today we're doing General Chemistry 1.2 Scientific Measurements. So how can we make quality measurements? First is correct value, so just reading the correct measurement. Second is significant figures, which is the emphasis of today's lesson, and this is like if the decimal point correctly represents the measuring device used. So if we use a scale versus a graduated cylinder, how would we compare significant figures? Finally, units. We always add units to our answer. So now, significant figures. So first, we have non-zero digits are always significant. Any zeros between two significant digits are significant. So if we, as we see, 0.5003, all of those numbers are significant as it's between those two numbers. And then finally, 3, which is a final zero or trailing zero in the decimal portion, only those zeros are significant. And so there are some examples below which you can see. Also to remember in significant figures is you always measure to the uncertain digit. And I'll explain what this means. So here we see in our graduated cylinder, we always measure to the bottom of this meniscus, right? So we know it's past 21. We know it's past 21.5, 21.6. So we know it goes past 21.6. And then the uncertain digit, we always measure to the uncertain digit, right? So we know it's 21.6. Our uncertain digit is between this 21.6 and the 21.7. So we would estimate this. We would say the correct measurement for this would be 21.61, maybe 21.62, something like that. So we know the digit and then we measure to the uncertain digit. Next, we have some addition and subtraction steps. So first, you count the number of significant figures in the decimal portion only of each number in the problem. Then you add or subtract in the normal fashion. And finally, your final answer may have no more significant figures to the right of the decimal than the least number of significant figures in any number in the problem. And let me show you this with an example. So here we have 56.5634 plus 12.34 equals 68.90. Now why do we have only two decimal places in the answer? So we count the number of, step 1, we count the number of significant figures in the decimal portion only. So this is four figures here and 2 here. And then we add in the normal fashion, and our final answer may have no more significant figures to the right of the decimal place than the least number of significant figures. So our least number of significant figures in the decimal was 2, and it must have that many. So it's basically 68.9. And then we also have multiplication and division steps. So the least number of significant figures in any number of the problem determines the number of significant figures in the answer. So here we see 8.56 times 5.1 is 44. So why? This, we're looking at the entire number. So this is 3 significant figures. Well, this is 2. We use the one with the least amount, which is 2. So when we multiply this out, it becomes 2 significant figures, which is 44. Accuracy versus precision. So accuracy is how close a value is to the actual value, and precision is how close a value is to another value that has been measured. So you can be precise but not accurate, and this is usually due to wrong measurements. However, if you aren't precise, then you aren't accurate. And so this dartboard below kind of demonstrates the accuracy versus precision thing. And now we have our quiz. So I'll let you guys work through this, and then I'll release the answers slowly. So go ahead, work on question 1. So here is the answer to question 1. Question 2. The answer to question 2. Question 3. And finally, question 4. And those are the answers for number 4. Number 4, ruler B can also vary. It doesn't have to be 1.47, 1.46, 1.45, something like that. But between 1.4 and 1.5, something reasonable is acceptable. And that is all I have for you guys today. So thank you for joining this lecture.